Hey folks, welcome back. This is Joel, and in this video, we'll talk about micro-segmentation using private VLANs, right? What do I mean by that? So let's hop on to the topology over here. We have a L2 switch here, okay? And this whole L2 domain is part of, let's say, one subnet, 192.168.1.0/24, right? Let's assume this guy is .1, .2, .3 and .4, and your default gateway is say at 254. Okay, so right from the addressing, you can understand that all these guys are in the same VLAN, they are on the same broadcast domain. Okay, now let's pick a couple of the hosts, right? Let's say you have the H3 and H4. When these two guys talk, what is going to really happen? And I'm mainly talking about the data plane, right? I'm not going to get into the ARP and all of that. My assumption is that all of that is pretty clear. So what is going to happen when H3 talks to H4? The traffic is going to go all the way to the switch, and the switch is going to send it down this particular path. It's going to be the same in the reverse direction as well. Okay, but let's assume my use case is that I want this traffic, which is going between H3 and H4, I want this traffic to be sent to some sort of a centralized firewall. How do you do that, right? So at the end of this video, what we'll establish is how the traffic can be sent all the way here, and then from here get redirected to the router, right? In this case, I'm going to be using a router, but this one can easily be replaced with the firewall as well, correct? So the whole point is to see how the traffic can be sent all the way up, down, and then go to the other host, right? And the same in the reverse direction as well. So that is what we are going to achieve right now. Again, there are different ways to do this. Cisco ASAs do it in a different way. There are different vendors, Palo Alto and all these people do it in different ways. But I'm mainly talking about, so I've been reading a bit about the Aruba's. So if you are a bit familiar with Aruba's data center portfolio, so Aruba has a CX 10K switch, right? And they actually employ the concept of private VLANs, right, to kind of do micro segmentation between the hosts which are in the same broadcast domain, same VLAN, right? So we'll set this up, and then we'll talk about it as we proceed. All right, cool. So let's look at what do we already have configured, right? So I've configured my H1, H2, H3, H4 as well as the router, right? So I'll quickly show you the configuration. So if I go down to my H1, you're probably gonna see show run interface Ethernet 0/0, right? There you go. Clear the screen a little bit. So this is what we have, right? Just the 1.1 interface, nothing fancy. So same thing is been configured on H2. So on H2 we have the 1.2. On H3 we are gonna have 1.3 and 1.4, right? So let me pull that configurations up just to kind of show you that. All right, so here you go. So this is on H4. You got it on H3. Then this is your H2 and this is your H1, right? Perfect. So we have the IPs in place. Now on the router, what do we have? Let's actually look at the router as well. So you see you have the 1.254 IP as well, right? So I can show you the running config on the interface Ethernet 0/0. That's what is configured. So I believe it's run. Yeah, there you go. Right, specifically 192.168.1.254, right? Nothing very fancy. All we have is the IP addresses on the host and the IP on the router. Now we'll start by configuring the private VLAN on the Catalyst switch, right? I'll be following this guide, right? Cisco has a pretty nice guide to configure this. So I'll be following this guide, and first we will examine the functionality of the private VLAN, right? And then we will explore how we can use this functionality to enable our use case. Okay, cool. So let's get on to our switch down here, right? So we've got the Catalyst 9K switch. So I'm gonna just clear the screen a little bit here. Okay, so let's get into the configurations. So first, when you configure a private VLAN, right, you need something called as a you need a primary VLAN, right? So let's configure that. Let's probably use VLAN 20 as our private VLAN primary, right? And when you do that, you'll get an error saying that your VTP mode should be turned off, right? Or it can be in the transparent mode. So let's do that first. So let's change the VTP to transparent, sorry, VTP mode transparent, right? So once you do this, next you'll be allowed to do the private VLAN related configuration. So let's do that now. There you go. So we are making VLAN 20 as our primary VLAN. Let's clear the screen a little bit. Let's move on. So once we are done with that, let's create the next VLAN. Let's call it as 501, and this is going to be our isolated VLAN, right? Like I explained earlier, isolated VLAN within the whole private VLAN domain is basically the VLAN on which the hosts can't talk to each other, right? So we are making 501 as isolated. Let's create 502 and let's make this guy as the community VLAN. Okay, so once you've made your secondary VLAN, so the isolated VLAN and the community VLAN are basically called as a secondary VLAN. So right, you can read more about this in the config guide, but you know, now that we have made the secondary VLANs, we'll have to associate these secondary VLANs to the primary VLAN, right? What was our primary VLAN? VLAN 20. So let's go to VLAN 20 and we have to associate this. We're going to say private VLAN association, right? And let's do 501 and 502. Okay, so there you go, we have associated it. Now to verify that we have done everything right, we can run the show command, which is show VLAN. I think it's private VLAN, right? There you go. So you've got 501, which is your isolated, 502, which is your community. All right, so the next step would be to configure the ports, right? So just to kind of double click on that, so what we'll be doing is we have 502 as the community VLAN, whereas we are going to have 501 as your isolated VLAN, right? So those are like two secondary VLANs which you can configure in case of private VLANs. And what we'll be doing is we'll be putting these two ports, right, in isolated VLAN, whereas we'll be switch the colors, we'll be using these two ports in the community VLAN, right? So from the general understanding of how this works, if H1 wants to talk to H2, it is going to be allowed, right? This is going to be inherently allowed because that's how the community VLANs are supposed to work, right? So the hosts which are part of the community VLAN, they are allowed to talk to each other, whereas the hosts which are part of the isolated VLAN, these guys are not supposed to talk to each other. So you will not be able to ping H3 to H4, right? So that's the general functioning of private VLAN. And on top of that, you also have what we call as the promiscuous port over here, right? So the promiscuous port, which is gig 105, all the hosts will be able to talk to that port, right? Or will be able to use that port. So all the H1, H2, H3, H4, right? All the guys will be able to send traffic to that port, right? So that's what we are going to set up, and we'll verify if that works as expected, right? And from there on, we will go to the next step, which is our final goal, which we have already discussed earlier. We want H3 to talk to H4, but via the router, right? The traffic has to be redirected to the router, and we'll see how we can make that happen. All right. So let's go back to our configuration. We are going to now go and configure the ports. Okay. Cool. So let's. So it's going to be 101, right? So let's get into the interface. Let's actually do this as a range command. So it's going to be 101 and 2, right? So let's use. Sorry, I think I missed the gig word here, right? So both the ports, right? The 101 and 102, both of these, we are going to put it in switch port mode, private VLAN, and we're going to call this as host, right? So so it's going to be in the mode host, and then we'll have to tag the VLAN as well. So we're going to say switch port private VLAN host association, and we'll have to first put the primary VLAN, which is 20, and then we'll also have to put the secondary VLAN, which is 502. Perfect. Now let's do the same thing for the other two ports, which is in the isolated VLAN. So it's going to be interface range 10324, right? Again, missed the gig one, right? So we're going to say same thing, switch port mode. Let's do private VLAN host, right? And then switch port private VLAN. We'll do host association, the primary VLAN, and we'll add the isolated VLAN, which is 501. Perfect. You want to verify what we have done? Let's just clear the screen a bit. What we could do is we could do show interfaces gig 1/0/1 switch port, right? So here you can see the information 20 and 502, right? It is accurately being shown, right? And you can see here the operational private VLAN as well. 20 and 502 is clearly shown. Okay. We can also verify the other guy, which is supposed to be 103, right? So over there as well, you can see 20 and 501 and 20 and 501. So the configurations have gone in. That looks good, right? While we are here, let's also do the promiscuous port, right? Let's configure the promiscuous port. Let me clear the screen a bit. So what's a promiscuous port? It is interface gig 1/0/ I believe 5, right? So how do you configure the promiscuous port? Let's do switch port mode private VLAN, right? And the mode is going to be, instead of the host, we'll have to put it as promiscuous. Okay. And let's attach switch port private VLAN, and we'll have to do the mapping here. Mapping the primary VLAN of 20 has to be mapped to we'll have to add all the secondary VLANs, which is 501 and 502. So I can just put a dash and I can say 502. Perfect. That looks fine. So with respect to this, I think all the configurations are good now. Let's just verify if the interfaces are up. Looks like they are up, right? So now time to verify, right? So give me a second. Let me pull in the wire capture here. All right, so I've pulled the wire capture here and I'm doing the capture on this port, right? The gig 105, and that's what you see over here, right? So moving to our other screen down here, time to do some verifications, right? Let's see if, so I'm gonna probably keep this a bit at the bottom. Let's move this a little bit on the top so that it's visible, right? That's good. So our whole idea right now is to, let me just pull this a little bit down. Okay, so our idea right now is to first let's see if the community VLAN works as expected, right? So let's get into this H1, right? So let me clear the screen a little bit. So we are on H1, and let's see if I can ping the host, the other host, that is H2. It is 192.168.1.2, right? The ping works, and you can see that traffic is not sent to the router, right? It's not sent on the promiscuous port, because that traffic gets switched locally on the switch itself, and you see connectivity is working. Let's see from the community VLAN port, am I able to ping the router, right? So am I able to talk to the promiscuous port, right? Let's check that. Ping 192.168, the gateway is 254, right? So this traffic should ideally show up here, and there you go. You can see the ping traffic is showing up. Perfect. So what have we verified now? We have verified that we've got, we know that these two guys are in community VLAN, and as a result, these guys are able to talk to each other like this, and they also have connectivity to the router because the promiscuous port allows it, to have that connectivity. Okay. Now the next important thing, right? H3 and H4. First, let's check if H3 is able to talk to H4. And then we'll check if these hosts can also talk to the router up there, right? So going back here, so let's go to H3, right? So again, let's also pull our capture so that it is visible. Yeah, so the capture is visible on the top. So first, let me do a ping to ping 192.168.1.4, right? So that's H4. And as of now, you see I'm trying to ping, things are not working. You can see the broadcast is reaching on the top, but you see there is no reply, right? You can see the ARP request is coming all the way to the router, but you're not getting anything, right? And at the same time, ideally router is supposed to drop broadcast, right? So things are working as expected, right? So what we can understand from this, let's try once again if you want, right? So let's try once again. 192.168.1.4, you can see the broadcast hitting the router on the top. So what's really happening in the background is when you're trying to talk between, let's go back to the thing, when you're trying to talk between H3 and H4, the switch is not switching the traffic because these ports are isolated VLANs, right? So that's the whole point of putting, that's the whole point of this secondary VLAN called isolated, right? It doesn't allow, this communication is not allowed. So because this guy is trying to do an ARP for this host, gig 105 is a promiscuous port and we are allowing that VLAN. So that's why the ARP request is even going all the way up here. But because this is a router, this guy is dropping the ARP request, and as a result, the communication is not succeeding, right? So now this is perfect till now what we have spoken about. Let's also, while we are here, one last thing, let's also check if we can talk between H3 and the gateway, right? Can we see if this works? Let's check that. So let me get rid of that. Let's go back to this thing. Let's come back here. Let's see, instead of pinging, let me clear the screen a little bit. So instead of pinging, okay, I think that went through again. Let me try in a couple of seconds. Okay, so instead of pinging 192.168.1.4, I'm gonna ping 254, and there you go, things are working, right? And my capture should also show that. There you go, my capture is also showing that. So what we understand from this, the port in the isolated VLAN is able to talk to the promiscuous port. Perfect. Till now we have just reinforced our learning about private VLANs, which we all probably studied during our CCNA, CCNP days. Now there's a very neat trick here, right? There's a very interesting trick. And what's the trick? Let's actually go back to the topology, because again, I want to reiterate what we want to do here, right? So till now we have really not accomplished our goal. We just verify that private VLAN works, but how is it really going to help us? So we have this guy in .3 and this is your .4, right? In the same subnet, right? And right now, because these two are isolated VLANs, when H3 wants to talk to H4, the ARP request is sent here, and from here the ARP request even goes up, correct? But then R3 is dropping that ARP request. But if you remember, again, this is networking 101, you might have read about ARP proxy, right? So that's what we are going to be using. So we are going to enable ARP proxy on the router, right? And when you enable ARP proxy, right, the whole point of enabling this is the router will answer the ARP request, right? Because it knows that there's ARP request coming in and it is connected to the segment, right? It is connected to the segment which on which the target host is residing, right? So in this case, what really ends up happening is, if I just have to break this down, so H3 will ARP from here. You're going to be ARPing for H4, right? So that request is gonna go all the way to the router, but the router will reply back. So there will be a ARP reply coming from here. So that's the whole point of proxy ARP, right? ARP proxy, proxy ARP. So what is going to happen is you're going to have a ARP reply from the router back to the host. But instead of actually replying back with the MAC address of H4, router will actually reply back with the MAC address of R itself, or router, or basically this interface. So we'll verify that in the packet capture as well, right? So because ARP reply has this MAC address, what really happens is when H3 is now creating its L2 header, it is going to send the packet, right, destined to the router. The router then is going to send it all the way like this, right? So that's the whole point of the ARP proxy concept, right? And by using this trick, what we are doing is we are redirecting the traffic to this device right in the middle. Now in this case, what I have is I just have a router, and I am going to probably put a couple of ACLs to show you that I can do some sort of security filtering. But in actual production networks, you can actually replace this with a firewall, right? And once you replace this with a firewall, you can actually do proper, stateful filtering. You can do deep packet inspection. You can do, SSL decryption and a lot of fun things, right? So that's how you can insert a firewall between two hosts which are in the same subnet, right? So let's come back. Let's do our game plan. So what we need to do right now we have made sure that R3 or H3 is not able to talk to H4. But after doing this configuration, ideally things should go. So what we'll do is, let's go back. right? So let's go back here. Let's also keep looking at the packet capture. The only configuration change I have to do is I have to go on to my router, right? And currently the configuration on the interface is this one, right? So what I'm going to do is I'm going to get inside the interface 0/0. Clear the screen a bit, right? First let's enable IP proxy ARP, right? And then we also need to enable local proxy ARP because we are trying to do proxy within the same subnet here, right? So once you do that, what really happens? Let's go back and retest, right? Let's do a retest right now. Before doing the test, let's observe that the ARP table on the host, right, is actually doesn't have 1.4, correct? But now I'm going to send a ping request to 192.168.1.4, and this wasn't working earlier, guys. But now, okay, there you go. You see the ping went through, right? But let's observe what really happened here. So you see the ARP request came in here, and if I look at the source MAC address, it is coming from 30, right? And that is actually by MAC. So if you see here itself, you can see 3000, right? At the end, you can see the MAC address here as well, 3000. That's nothing but my H3. So the H3, right, is sending a ARP request to a broadcast, packet. This is as expected. But then ARP reply, which is coming back. So this is actually ARP reply, right? So the ARP reply, you can see here, this is ARP reply, and the ARP reply which comes back is actually coming from 5000, right? Ending with 5000. What is 5000? You can see here 1.254, which is nothing but the router here, right? We can also verify here, right, by going to show interface Ethernet 0/0, and you can see the MAC address will show up here. Let me just scroll a little bit up. Yeah, here you go. Perfect. So what we understand from here, ARP request is going to the router, and the router is replying back with its MAC address, right? So the ping request is sent by H3 to what? The router. Because if you see here in the L2 header, you have 3000 and you have 5000, right? So the ARP request is going to the router. What does the router do? The router, since the router already has the ARP entry for the host, right? Let me clear the screen and show you that. Sorry. Let me clear the screen. Okay, so if I look at show ARP entry here, you can see the router already knows that 1.4 is at this particular MAC address. So it doesn't really have to ARP again, right? Because it already knows, I mean, we already pinged 1.254 from H4 earlier. So it already knows the MAC address of 1.4, and as a result, the moment it sees this ARP request, it is able to kind of take the L2 header, and you can look at the L2 header here. You can see going from 5000 to 4000, right, which is basically the frame which is being sent from the router all the way to R4, right? So the ARP request has gone successfully. And you can then see this is like a so then you see the reply, because your host 4 has to talk to host 3, right? The same process happens again. So there is another ARP request coming from H4 towards H3, and you can see in the in the ARP reply, again it's the same concept, right? The router in the middle is kind of intercepting. It is playing the role of a proxy, and you can see the ARP reply as well. So if you look at this is the next ARP request which has come. So if I come down, let's look at this guy. If you look at the ARP reply has actually come from ending with 4000 all the way to 5000, which means it's going from H4 to R1, or basically the router, right? And that ARP reply is then forwarded by the router, which is 5000 all the way to 3000, which is H3. So you see how router has very conveniently introduced itself in the middle of two hosts which are part of the same VLAN, with a part of the same broadcast domain, right? This just enables a lot of things, right? Like for example, you saw right now, again, let's try once again, right? So we can see right now the ping is working, correct? So you see the ping is beautifully working. But if I want to prevent H3 from talking to H4. If I want to do some crazy firewalling, I can do. What I have on my router is I have actually a couple of ACLs which I've already so I think show IP access list, right? So there you go. I have an access list which which allows the traffic between R3 and R4 and in the reverse direction as well. So I can ideally put this, right? So I can go to, by default all the traffic is allowed, but at the same time, right, if I want to explicitly allow it as well, I can do it. So you can see interface Ethernet 0/0. I can do IP access group, right? And then the name of the access list, which is gonna be this guy, right? And I can, let me just clear the screen a bit, right? So in, and I put it in this direction, right? So what I did by this is I'm just allowing the communication between H3 and H4, right? So the communication should still work, right? There you go, it's working. But now what I'll do is I'll use the other access list which I've also created. So if I show you that access list, it is show IP access list, right? So there's another access list which is just denying the communication between H3 and H4. So I can now do that as well. So I will get rid of this access list, right? And instead I'm going to replace this with the deny one, right? So we'll just grab this name from here and we'll replace it and we'll enter. So now that we have put the deny access list between or basically on the interface on the promiscuous port, right, on the router side, now what happens is if you do the same ping, things should not work. There you go, right? Things are not working, and you should actually see that here in the packet capture as well. There you go, right? Destination unreachable, communication is blocked, right? It's a very evidently we can see that there is some device in the middle which is trying to prevent the communication from happening. Perfect. So this is something, this is actually a very simple concept, right, of using private VLANs to enable micro-segmentation, right, especially within the same VLAN, within the same broadcast domain, right? How you can have two hosts, how you can kind of either enable communication or disable communication, or also redirect the communication to a third device like a router or a firewall. Private VLANs really plays a very interesting role over there, right? So hope this was useful, just to kind of finally give a full closure on this. What we ended up doing was we actually put H3 and H4 in isolated VLAN, so they were not able to directly communicate with each other. And we also know that the isolated ports can also talk to the can talk to the promiscuous port. So this was the promiscuous port, right? So what we ended up doing was on the router we enabled ARP proxy, right? So we enabled the proxy, ARP proxy, whatever you want to call it. The moment you did this, what happens was the ARP request which went here, the router started answering the ARP request with its own MAC address, right? So as a result, ARP request was answered and all the traffic from H3 was sent to the router, and the router already had the ARP entry for H4, so it started sending traffic like this, right? And the same thing in the reverse direction as well goes like this. So now the router was able to successfully install itself in the middle of the data path, and that way you can do all sorts of fun stuff in the middle, right? All right, guys, so hope that was useful. That was a quick one. Thanks a lot for watching. Have a good one. Bye.